This video instruction is designed to help you get set up for the saltwater density lab. Now before you watch this video, I suggest you watch the presentation that I've created that gives you the main goal and some tips on setting up your procedures for this lab. This will be the lab in which you have your first experience with a program called Logger Pro. I'm going to show you how we're going to use that for a lot of labs in here. So this is Logger Pro. Okay, and when you open it up, it's going to look something like this. I'm having you start out with a blank page. All right, because what we want to do is to set it up to be able to put your data in here to create a graph so you can ultimately get to determining whether or not what we're going to gather in the lab is extensive or intensive. Okay, so let's go over here and find these two columns. What you have is the Logger Pro is set up with only two columns of data, because most of the time when you're in a high school lab, you're going to be collecting an independent dependent variable. Okay? So can anybody tell me what an independent variable is? No? Really? No, that a variable that doesn't change, or one you cause not to change, might be called a constant. Okay? And so what we want is an independent variable, something you do change. Okay, so the independent variable, when you were in middle school, you might have called it the manipulated variable. Okay, do y'all remember that term? Okay, so what is a manipulated variable then? It's the one that you are purposefully changing, right? Okay, so if you've got a manipulated variable, then if you're using those terms, then you've got what's called a responding variable. And what is Can anybody tell what the responding variable is? It's the result of what you changed? Okay, yeah, kinda, pretty much. If you change your independent variable, then as a result, the responding variable changes, okay? So the terms that we'd rather use are independent and dependent. And there's reasons for that, because when you get into higher level science, manipulated doesn't really apply some of the time, because the manipulated variable, you might not actually be manipulating a variable. If you're going out into nature and doing research, you're not looking for the manipulated variable because you're not going to be manipulating it. Okay, you're going to be observing changes and looking at how they might cause something else to change. Okay, so that's one of the reasons we don't use manipulated and responding variables. It works fine in the lab. It doesn't work in other areas of science, maybe in the field or something. Okay, so when you're graphing, where does the independent variable or manipulated variable go? It always goes on X. Okay, so if you look at this data set here, there's an X here. Okay, so double click that, and let's set up that variable to look the way we want it to look. Okay, first of all, we need to figure out what are we going to call this thing. Okay, if that's the independent variable, what are you changing in the lab? Huh? The amount of salt. Okay, so let's now we need to be specific about it. What is the amount? How are we measuring amount here? In grams, which is a measurement of what dimension? Grams, right. Grams is the units of measurement. What is the dimension it's measuring? Mass, okay. So for X then, we want to call this the mass of salt. Got it? Question is, how much water did you put it in? In your procedures for your lab group, you must say mass of salt in and tell me how much water you're using. That make sense? Everybody may have a different set of procedures, and so I'm not going to tell you what to put there. Okay, so I'm going to put in here now, of course, you're not going to put X volume of distilled water. You have a specific amount that your group's going to be using. Okay? Now, the short name is the one that goes to the top of this column. That's the way it works. So we're just going to use something really simple like, how about mass salt for now? Okay? And what units are we going to use? Grams. So we're going to just put in G for mass. Okay? For the units of mass. Okay? Got it? And we click done. And look, both the X axis on the graph is set up for you properly, and the column label is set up for you pretty much properly. All right? Got that? Now, what is the responding variable or the dependent variable in this lab that you guys have designed? What have you designed? Density. Good. So let's go up here and click Y. And do the same thing. Okay? Fill in what you're going to put up there. Don't wait for me to do it. Do it for yourself. What are you going to put in up there? You can talk to the other people in your lab group or whatever, but if you're going to put in density, density of what? What units of measurement? All right, so we're going to click right here at the very top. We've got our column labels on the graph set up. We've got our axes labels set up here. Now we're going to put in a title, and we're going to click right here. Okay? Now, I'm going to let you and your group figure out your own title. Here is the form that you should write all titles in this class. And before I tell you the form, let me ask you this question. Will you remember this the next lab? If you don't remember it for the next lab, that's on you. What do you need to help you remember it for the next lab? Who said that? I heard somebody say it. There you go. See? And you're supposed to have a tab in your ring binder now labeled for labs. So now you've got a place to put notes about labs, like how to properly write a title for a graph, or how to label your column and axes labels. Okay? All right. Now, there's a way that I'm going to give you that will help you write solid titles for labs, for lab graphs rather, that'll work out almost every time if you have an actual lab, okay, and you're collecting data, where you have an actual independent variable and an actual dependent variable. Now, having said that, let me explain something. There are graphs where you don't actually have an independent variable, okay? In those graphs, you're comparing two variables, but one isn't independent or dependent. They're kind of independent of each other. You're just comparing the results of how those two compare, okay? But for this system here, this is for writing the titles for those labs where you actually have an independent variable, okay? And so what you want to do is write the following words. The effect of. That's the first thing you want to write. All right? Then you want to describe in a word or two what your independent variable is. And I'm just going to put in parentheses independent variable, okay? But you don't put that in there. You can put that in your notes if you want to. But when you're actually typing out your title, you're going to plug in a 1 or 2 word description of what your independent variable is. Okay? The effect of the independent variable, whatever that is. Okay? And then you're going to have on the, and what do you think it's going to be on? Dependent variable. Okay? And it's that simple. Now, if you remember that form, I won't tell you every time we do a lab that has a graph. I'm expecting you from this point forward to know it. So make sure you have it written down somewhere that you remember what the form is supposed to be. Okay? I'm going to let you and your lab group design your own title for your graph. You got it? You have to put it in there. Now, you're not going to use this. Remember, you're going to replace the words and the parentheses independent variable with your own independent variable, whatever the description actually is. And you're going to replace the words and parentheses for dependent variable in your graph. Everybody got that? All right, so just for me to illustrate that point, I'm just going to plug those words in here. All right, and you'll have to design your own title based on that. You got it? Okay. Now then, so you're going to go back in the lab And using the procedures you and your group have designed, you're going to figure out how concentration of salt in a sample of water is going to affect the density of that sample of water. Okay? Now, you may get back in the lab and realize, the procedures we've designed, these aren't really working. I need to make some modifications. That's fine, as long as you write it down in your lab logbook. Okay? You can draw a single line through, say, a procedure you want to change, and then draw an arrow to someplace where you're going to write what the change in that procedure is going to be. Or you can draw a line through it and put C, A1 down below or something. Okay, whatever. Just make sure it's clear how you're changing your procedures. You got that? Now, having said that, let's be clear. When you're writing in your lab logbook, you have to write in pen. And any mistakes you make, you never scribble it out. You don't use whiteout. Okay? You don't tear out pages. If you make a mistake, you draw a single line through the error and then write in whatever the correction is. You with me? All right. Now what I'm going to do is I'm going to turn you guys loose to go get your lab data. All right? And then what we're going to do is come back and help you get set up with your graphing itself. You with me? Because I don't want to feed too much to you right now. You'll never remember it after the lab anyway. You got that? So let's go back to the lab now, and you're going to start collecting data to try to figure out how it is that concentration of salt in water is going to affect density. All right? In your Google folder, you're going to have the post-lab document already partially made out for you. Now, I've sort of given you a bit of a head start on some things you're going to be expected to do by the time we finish this unit. So pay attention here. This is what your post-lab document looks like. Make sure you're putting in your name, the date, class period, and so forth. If the description is not already written out for you, and my name is written out for you, make sure you put those in the upper right-hand corner of your papers, okay, including your post-labs. Now, the procedures that you guys in your lab group finally came up with after any changes you made during the lab, that's what you're going to detail right here for me, okay? You're going to tell me what procedures you used. Now, this is a formal table. This is the form of a formal table, okay? In a formal table, you must have a table label. See what I'm highlighting there at the top? A table label has a table number where you say table 1 period. If there's more than one table, it's table 2 period and table 3 period and so forth. And then a description of what's in the table. The two things that are key, tell me what's in the table and why it's important. Okay? Then you have column labels. Notice that the column labels have the units of measurement listed there. You don't put units of measurement in the columns themselves, only in the column labels. So if I were to put data in this column right here, this first column, okay, I don't have any units of measurement there, only numbers. You with me? Yeah. Now I've given you a pattern in the first two column labels. The last two column labels I expect you to fill out for yourself. All right? So I want you to use these as kind of a pattern and figure out, well, what do I need to put over here, okay? What else needs to be measured in order to get everything together? I mean, what else do we have to have for density? That make sense? All right. So you're going to complete the table in your post-lab report. Got it? You with me? Now there's a link to a YouTube video up here. Listen carefully. If you click on that link and watch the YouTube video, it will go through everything you need to know about formal tables and graphs, okay, in a video. So that if you'll follow that video and do your homework, you know, you're going to have a good post-lab. Got it? All right, now, then down in the next section is where the graph's going to go. Now we haven't finished your graph yet. So I'm going to go back over to the Logger Pro program, and you notice I've already put some data in these columns. Those are not your data. These are my data, okay? Now the problem with Logger Pro is it won't. It doesn't automatically show the correct number of significant digits. Make sure when you fill out your table has the correct number of significant digits. You got that? If you need help, let me know. I'll help you with it. All right. But make sure you got the right number of significant digits. Now, looking at when I put the data in here, notice how my data seems to be kind of a flat plateau here. You see how it's flat along here? Now that's a problem because there might be a pattern that I can't see. I need to spread out the data so it fills the graph. You with me? Spread out the data so it fills the graph. Now, here's an easy way to do that. Since it's all kind of squeezed together vertically, up and down, I'm going to go over here along this vertical axis, and I'm going to right-click. And see where it says Auto Scale? I'm going to auto scale it. Notice it spread it all out. See that? Now, there's a problem because this data point right here, right around the number 1, is kind of like stuck on the line. I want to get it off the line. So I'll move the cursor to where I see this emblem just below the horizontal axis. And that allows me to right-click and hold and pull it out a little bit. Now I can see where that data point is. Does that make sense? And over here in the upper right-hand corner, I got a data point stuck right in the corner. I need to move that out. So I'm going to go down here. See that same emblem's over here. Pull it back from the edge. And then I'll pull it back from the top up here in the same way. Now I can see all the data points clearly. You with me? And you can change what the data points look like. I don't like these little red circles. Maybe I want to change it to, let's make it sort of a dark blue. And let's see, there's a place to change what it looks like. And instead of an empty circle, maybe I'm going to use a circle. Now you don't have to do this, but it kind of makes it easier to see. You with me? All right. One more thing, other than what we talked about before you went into the lab, you need a best fit line or best fit curve. Now you should already know what those are, but a best fit line or curve does not connect the dots. It's sort of splitting where the data goes. Now, you're never going to have in a lab a perfect straight line or a perfect curve. It just doesn't happen. Okay? There is one lab where it almost might happen, but really, if you looked at it close enough, it's never perfect. Okay? So, nature doesn't work that way. But if we have pretty much a straight line, there's a real simple way to make a best fit line. Okay? It doesn't work for curves. It only works for lines. And you see this icon right here? That if you just click that icon, it's going to put a best fit line on there. How about that? All right, that's pretty easy, isn't it? Now, the question is, let me go back and let's look at your report. How do we get the graph on here? Well, it's simply copy and paste. Let me show you how that works. So I'm going to go over here to where the graph is. I'm going to click somewhere on the white space. I'm going to right-click on the white space. Okay, and I'm going to copy. Got that? Once your graph is finished, you copy it. You go back over to your reporting document and right-click paste, and it'll be there. There's your graph. How about that? Yes?
You know how you said we have to do more than just like murder reports?
Yeah, you see how I've got, what have I got? 1, 2, 3, 4, 5, 6, 7 data points?
So, are we going to do this again as in class review? What if they come back and
Y'all didn't get at least 6 or 7? How many data points you get? Only 3? You got 5? 5's kind of on the low side. 3's way too low. So you can decide how you're going to do that, okay? If you want to stick with 3, here's what I'm saying. I'm saying if you're going to stick with 3, I'm going to count off points because you really don't have enough data to tell whether it's a straight line or not. See what I'm saying? Yeah. Without more data points, you can't tell. All right? Talk to me about that outside of class. Okay? We'll talk about it later. All right? Now listen. This graph is not finished. Graphs have to have figure labels. Let me go back up here and show you the table. Table labels go on top of the table. See how it's on the top of the table? Figure labels go underneath. So I'm going to I'm going to hit it. I'm going to go past the graph and I'm going to type in figure 1. Okay? Now I'm going to describe what's in the graph. So listen, I'm looking for 3 things in a figure label. Just like the table, I want to know what's in it and why it's important. But more than those 2 things, with a graph, I want to know what is the analysis, okay? Graphs are tools for analysis. So you have to tell me what the analysis is. The analysis is, what kind of pattern do I have here? Just exactly how is the independent variable affecting the dependent variable? And the data that I put in here tells me that I've pretty much got a straight line, which means that increasing the independent variable, in this case the amount of salt in a volume of water, is increasing the density. That make sense? You with me? I mean, that's pretty straightforward there, right? Now, here's something you need to know for the test on Friday. When you have a pattern like this, it has a name. When you have a pattern like this, it has a name. It's called a direct relationship. You need to know that. We'll talk about what an indirect relationship is later. Inverse relationship. We'll talk about that later. But right now, you need to know if you have a straight line with a positive slope, that's called a direct relationship. But when you're describing the pattern here of the data, when you're describing what the analysis is, you want to not just say it's a direct relationship. Say every time I increase the concentration, it also increases the density. You see what I'm saying? If your data shows that. Got it? You with me? So you got to have a figure label. Now, there's one more thing you got to do to finish the lab, and it pretty much tells you what your conclusion is supposed to be about. Now remember, we talked about this on Friday. What this graph ultimately was about was whether or not the increase in concentration and its effect on density gave you an extensive or intensive property, right? And so that's what you're going to address with the conclusion. Now, when I say you're going to address it, we're talking about it's kind of an argument. It is an argument. Okay? Now, in science, we make arguments without being argumentative. Okay? So you have to make a claim. Okay, this is intensive or this is extensive. You have to tell me what the evidence is. Here's how I know that because my pattern in my graph shows that if I did this, this happened, and so forth and so on. Right? And then reasoning. So explain your reasoning. So claim, evidence, reasoning. Sometimes I just shorten that to claim and justification. All right, which is why I have justification written here. Right? But claim, evidence, reasoning. If you remember those 3 words right there, that's going to help you a lot. Claim, evidence, reasoning. You've probably heard that in other classes. Okay, claim, evidence, reasoning. All right. So your conclusion should be written with that in mind. Detailed arguments, claim, evidence, reasoning. Everybody with me? All right, so that's your post-lab report. Now, let's say you've got a graph here, and you need to go back and tweak the graph. You don't have everything just like it should be, you know, and so now you're kind of stuck. What are you going to do? Well, you can save this graph to your flash drive. That's one of the supplies you're supposed to have today. Okay, so you save the graph to your flash drive, and I sent you in your email a link to download this Logger Pro program to your home computer if you want to. Don't have to, but you can. All right? Then you can open it up on your home computer and work on it before you copy and paste it. Got that? It'll save you having to come back in here if you don't want to. You can if you want to. You can use the computers in here, almost anytime you want to, okay? But if you want to get it done at home, that's an easy way to do it.